Thank you everyone for joining. It's a pleasure to have your presence because I know a lot of interesting talks are going on in the room, but you guys made the right decision to be here. And I'll make sure that I make sure that you guys don't regret your decision. Thank you. So this is my topic, how I met your algorithm. For those who don't know the reference, this is from a show, How I Met Your Mother. It's one of my favorites. So just wanted to do something around the title and make it a bit engaging and interesting, you know. So this is How I Met Your Algorithm, a post-quantum love story. You can see the MLChem, MLDSA/DSA. And who am I? So I'm not someone really extraordinary. I'm just another soul in a random corner of the world living in quiet fear and paying taxes. You know? Nothing extraordinary. And when I realize this fact that how small I am, it really makes me think, okay, I'm really insignificant. And how can I make something significant now? That is the thing. So that is me. Okay, this is a very basic slide. This is what I usually present in schools and universities that I'm invited to, and where they want to understand about what PQCA is. And also this is for the slide who are not very informed about PQC, because rest of the presentation would go on waste. So this is a very basic talk. I know you guys are expert, but please be there with me. Okay, so this is my cat, Alice, and this is my other cat, Bob. Yeah. Although they live in the same house, but they have two favorite spots in different rooms. You know, although they can talk face to face, but their room is separate. So, but they love to talk. You know, so how they talk from different rooms is they sit on the internet. You know, and they are really intelligent cats. They know that this internet is very secure. You know, and they are well aware about the fact that this communication that that is going on between us, it's secure using the classical cryptography. They even know about cryptography, you know. So they talk and talk and talk, and you know, this is the ciphertext. Nobody else in the room, in the house, can really understand what the hell they are talking about. And this has made me really mad. I'm so much interested, like, what the hell are they even talking about? You know, they live in the same house. They have been there from very early age, but they still talk, and their talking never stops. So now this fact is driving me really crazy, you know, to really understand what exactly are they talking about, you know. So how do I solve this problem? So I really don't have a good answer. So I watch a lot of Doraemon. So this time I went to Doraemon so that he can bring something really interesting out of its pocket. And this time he brought quantum computer. And it's not just a random quantum computer, it's very powerful one. Yeah. And using this very powerful quantum computer, I can actually see what they are talking about. So the ciphertext, which was, they thought it's good, and our owner really can't understand it, using the Doraemon gadget called quantum computer, I could really see what they are talking about. And this is one of the examples which I found out what they were talking about. You know? And I don't know how. I mean, they are intelligent, of course, I told them. I told you guys. So I don't know how they found the fact that I can really see what they are talking about using this gadget and all. And this made them cry a bit, as well as our cat, Bob. But as the fact that they're really intelligent, they thought about, how do I solve this problem? You know? So they said, let's use post-quantum cryptography. And this is where PQC throws the magic. Now, the insecure communication that was affected by the quantum computers is safe again. So the method is same. They have public key and private key, but this time it's post-quantum public key and the post-quantum private key. Using this, their communication and their whatever they're talking about was once again secure, and the ciphertext is back again. So I could find the answer for a very short time, how to solve this problem, but I've lost again, you know. And the part of the problem is, why am I even talking about this? Because a lot of people know that quantum computer is still not there. And it's correct, it's still not there. But that is not the problem. I think there's a bigger problem, which we will be discussing in a few minutes. But before that, now I cried, because I can't really see the, yeah. Yeah, so I was preparing presentation last night. It was not ready till today. I think I just finished 5 minutes ago before the presentation. And my sister last night at 2 a.m. out randomly she sent me this YouTube video link talking about this Nobel Prize. She is from literature background. I don't know how YouTube recommended her this video. Now you can see this is the 2025 Physics Nobel Prize winner. There are 3 guys, and they won this Nobel Prize for quantum physics. So this is like in this video, he's trying to show, okay, this brings quantum physics from subatomic world to the chips. Even if the quantum computer is still not there, but there are a lot of discussion going on, and you can really see that maybe in few years there will be a very good quantum computers which have a lot of significance but is affecting our security. So you can see we have been working in quantum physics for a very long time, and part of the fact in the suggestion of this video, below that, there was another TV news channel, and the reporter was telling about the same prize award, but she was discussing also about this will have the need of post-quantum encryption. I've never seen like the news reporters talking about PQCA and using in fact, these terms, post-quantum cryptography. So the thing is, a lot of people have mixed opinion about PQC, whether to adopt or not, but I don't care. But what I really realize is how beautifully they have created this new mathematical algorithms. This is a win-win for mathematicians and the cryptographers. They've never get this much recognition, and if a threat like quantum computing and quantum attacks is bringing a lot of recognition to those guys, so I'm really happy for them. And this session of NIST rounds, what effect it created in my life was, I could really see like these guys, even if the quantum computer is still not there, they have done a lot of good things, and the mathematics they have used, the cryptography they have invented throughout these years is such beautiful. I really admire, although I don't really understand how mathematical thing works in new algorithms. I try to, but I really can't get along with some of the algorithms. But I'm really happy for those guys, and it's also bringing hope in our life that maybe in future, if there is even more devastating attack like this, now then these guys also can bring some really, really stronger algorithms, and this hope is what we need in life. So congrats to those guys and kudos to you guys. I really admire them. Now back to the thing, what is the biggest problem? The quantum computer is still not there. The bigger problem is store now, decrypt later. Let us suppose there is some data. This is your encrypted data, and you guys really don't care because it's an encrypted format, but it is getting stored somewhere. It's getting stored somewhere, and let us suppose that maybe in future, let's say after 10 years, 15 years, there's a quantum computer available. What this quantum computer can do is, the data you thought was okay, not doing anything, it's encrypted format, we don't really care, but this is the encrypted data of your very highly secure information, long-term transaction details, and communications. But what it can do is, if in future there's a quantum computer, it can decrypt all your data that you thought was sitting quietly in encrypted format. We were happy, but this is the problem. If a quantum computer is there, it can decrypt your data. What you can do now, okay, so data is gone. The attackers can finally see what the problem was. Now what you can do, it's not only about the problem, it's also about the solution. What you can do is adopt PQC today, right after this talk. Then what effect it will have is the data from now on, which was getting decrypted, will be protected, even if there is a quantum computer. And I'm really sorry for the fact that I can't really do much for the data that is already lost. So this is a bigger problem than the quantum computer, store now, decrypt later. And there is another bigger problem, that is procrastination. A lot of problems are delaying this procedure of migrating to PQC, and I use the term called crypto procrastination, in short, cryptocrastination. In fact, I have a flight to Taiwan where I'm going to discuss about cryptocrastination for telecom infrastructure. So if you are guys interested, then you can come with me. Yes, and this is monkey sees, monkey does. I have a mentor who told me this analogy of monkey sees, monkey does. It's basically when you hang around with 3 guys, then the 4th guy, which I am, you will become like these. And it is a good thing in some sense. It could be bad in some sense, but for open source, it's really good. What if you could have seen like few years ago, you would not find many open source algorithms, open source projects and libraries which are talking about PQC. But now this is the whole group of PQC library and the projects that are covering the PQC algorithms, including OpenSSL, libOQS, PQCode package. And some of these are very much widely accepted. SimCrypt is from Microsoft. OQS provider was doing the same thing. A lot of people discuss like what is the scope of OQS provider now that OpenSSL 3.5 itself has PQC algorithms. The straight answer to it, like not every open source project and library are going to adopt all the new algorithms, PQC algorithms that are just for the research purpose. So OQS provider is a research project which is basically doing this. There are a bunch of PQC algorithms that are not NIST accepted, widely accepted, but you can play around with on your TLS OpenSSL library. And there are a bunch of libraries, such as the QRC open source RS. This is an individual guy which contacted me and he told me that, oh, this is even better from your Linux Foundation initiatives. I didn't get the time to test it, but maybe in some time. If we have more time, then maybe we can later discuss about what is the good thing. But these are the overall idea, and depending on your use cases and the best practices, you can choose any one of them. I would highly suggest OpenSSL. Yeah, but it's up to you, guys. And I tried my really best to show the relationship of OpenSSL with these projects. I wanted more green boxes, but how I'm doing the relationship is like, even if there's like a provider, even if there's like a supportive layer, even if it's like a fork, I'm giving it a green just to show what OpenSSL, what relationship status OpenSSL have with these other projects. So OpenSSL SimCrypt, I think it has a provider for OpenSSL. I'm not sure whether it's targeting the PQC one or not. OQS provider is basically providing the libOQS for OpenSSL. AWS LC is dependent on Boring SSL, and Boring SSL has a past history with OpenSSL, like its fork. And Bouncy SSL and OpenSSL, you know, under the OpenSSL library. And GNU TLS, it has a supportive layer for OpenSSL. So this is the overall idea. I don't think I have much time. I don't have much time to discuss more about this. But if I have more time, then we can give it another review. Yes, it's not a race. It's a marathon. Some people are not taking the initiative of PQC migration. But let me tell you guys, it won't be a very easy task. Of course, if you are an individual and you are a small business, then you can do it in a good way. But when your infrastructure is too high, you know, we have a lot of customers from bank and the defense back in Singapore, and their infrastructure is so complex that we are going like in a very good manner. That is creating firstly crypto inventory, providing a crypto visibility. Then on the basis of that crypto inventory, we are creating a migration strategy and roadmap. And using that roadmap, we are doing the PQC migration. I mean, we're still in the first and second part. Those parts still need to be done. But you can realize the fact that it's not going to be an easy process. You know? And once using that PQC roadmap and migration strategy, you do the PQC migration, and the stop is not there. You have to maintain the process and provide best practices. You need to teach your engineers, who are the backbone of your product and company, that, hey, man, this is PQC, and you need to take very good care of like how you do on a source code level and everything. And I solemnly swear that I'm up to no good. I'm not genuinely meaning this fact, but if you guys have ever seen Harry Potter, then this was like a map which on the first glance could not tell you anything. So these two Weasley brothers used to make a spell on I solemnly swear that I am up to no good, and it could open all the information about everyone. There is guy. It could provide a very good information, you know. Now, when it comes to cryptography, not a lot of organization knows what exactly is going on, what crypto artifacts they are using. So it's like a black box. They know cryptography is there, OpenSSL is there, but what algorithm is being used, what secrets, what keys are used. So I really want a magic spell like this to provide me those crypto inventory. And that magic spell, unfortunately, can't be there, but what we have is a crypto inventory. It's basically telling you all the information about your cryptographic artifacts. We call it handlers, we call it assets, whatever terminology you want to use. But basically what it is telling is providing complete crypto analysis and the image of your product's company. And this crypto inventory, what it needs, like crypto scanners on every level of your network and your project. So coming from your, let's say it's firewall or the load balancer, we do scanning on that level also. And some people really go with the source code library scanning and the CI/CD. That level also needs scanning. And you have network traffic analyzers, active analyzer, as well as the passive analyzer. You do with the KMS, you do with the HSMs, everything needs a scanner, and that's how you get then also you get 90 to 95% of inventory in the best scenario. I think 100% of crypto information you can't really get at this moment, but we'll try something out. So for this talk, I'm only focusing on the source code one, because all those things will need another session. But if you're interested, you can talk to me. I will suggest you some of the best practices. For source code level scanning, we have CBOM kit. This is an open source project from PQCA. What it does, it scans over your source code, and it brings the crypto library and the algorithms that your project or source code is telling about. So basically, it's scanning your functions, modules. Right now, it only supports Java as well as Python. So all the Java cryptographic library is there. It will provide you which is used where, which line is telling which information. And it's the source code one. And why? First of all, it's a very good tool. And why I'm even talking about PQCA? Because I have a history with PQCA. Yeah, you can see all the people here. And if you really focus on the most good-looking guy, yes, yeah, that is me. And I'm helping the Technical Advisory Council as a vice chair. All of them are really good-looking, but I think I'm there. Okay. So what we do as a Technical Advisory Council is we provide assistance and help. We admit new projects. We approve new proposals for new projects. We decide the life cycle changes, define what production-ready things mean. We establish community norms, workflows, or policies that are within the scope of a single project and other project, resolving technical matters and problems that affects multiple projects, and coordinating with cross projects. So there are 3 dedicated projects under PQCA which are going on. It's going well. It has OQS also. And the happy adoption of the PQC, so PQC could be adopted in many other levels, but the easiest protocol that a lot of people jumped directly was TLS, because it's practical and it's good to initiate it with, because a lot of communication is done being the TLS. So you can see the recent adoption of PQC in the TLS, whether it was your AWS, KMS, ACM, Secret Manager. Now they support Post Quantum Cryptography algorithms. And this year, this is the Friday, July 18th post. Now, by default, Kubernetes use Post Quantum Cryptography from version 1.33, if I'm not wrong. So you can see now, not only they are providing, they are going by default. This is what even OpenSSL also preach for. And the CloudFront, this is 1 month ago. The CloudFront, which is used in a lot of places, it's a service from AWS. It also supports hybrid MLCAM now, PQC. So you guys can understand the fact that people have already started adopting. While you are only discussing about PQC, what PQC is, they are actually doing the migration, because they've realized the fact that it's very important. And this is Stronger Swan. If you ever seen Strong Swan, now Strong Swan is your VPN open source project. I'm talking more about open source project because that was something open source and free projects I really like, and I contribute to them. So this is for your VPN. I am using Strong Swan from a very long time, and now they support hybrid post-quantum key exchanges. What it does is it has classical key exchanges, and on top of it, it's also doing multiple MLCAM key exchanges. So there are different 2 RFCs. You can try both one, but I have played a lot with multiple hybrid key exchanges. And now the Strong Swan has become Stronger Swan. How to make it the strongest one? For that, we are using something called eBPF. It's a very complex topic, and it will take a very good dedicated session for this. But you can see all the VPN, this Strong Swan, IKV2 policies were there. Now they are directly being used at the very network driver level. It don't have to go through the kernel networking stack and go to the user space and then do the kernel space thing. Directly on the very XTP is the network driver hook point. On that point, it's directly offloading all the IQv2 policies, so it has made the process more faster. Using eBPF, we are also trying to accelerate AES as well as the MLChem key exchanges. With AES, we have got good performance. If you want to know more about this, we can have a discussion after this presentation. And this is my wife left me after reading NIST SP 800-207. So this was the complaint from a guy. Now, there are a lot of experts in this room. Can anyone tell me what this NIST SP 800-207 is? Yeah. OK, never mind. So if you do Google, this is about zero trust architecture. So what zero trust architecture says is, whether any component is inside your network or outside your network, don't trust it by default and think that there would be some attacks in any scenario. So I think his wife misinterpreted with whether it's you're inside the house or outside the house, you don't trust by default. And this caused some problem. Maybe that was the cause root why the wife left. But anyways, this is the zero trust architecture, how we can make it post-quantum. So zero trust architecture, it's an architecture, it's a policy, all of these things. It requires a lot of things when we talk about zero trust architecture. But one of the major component is authentication and authorization. So for authentication part, MTLS 1.3 with PQCA algorithm you can use. For authorization, still not a lot of people are targeting on the PQCA algorithms. But in the zero trust architecture, standardized naming convention is PEP, PDP. This is policy enforcement point, policy decision point. And it basically, when you have two components, we go with the consumer and producer ideology. Basically, any two components, whether it's your host level or Kubernetes level, you just say, OK, this is the consumer of the functionality, this is the producer. So in order to make a request between this producer and the consumer, you make a service request. You go to the PEP, policy enforcement point, which is enforcing the policies. PDP is the main guy who's deciding which access control we have to give. So basically, it's nothing. It's just service request. The service request, it says, hey, man, I need some tokens. And these tokens, by default, utilizes elliptic curve cryptography and the RSA. So what we need is post-quantum JWT token, which are signed with MLDSA. Not a lot of people have done this. I think we were the actually one who started this. And we are signing it with MLDSA and using the PDP's private key. Now you have the token. So basically, now since you have the token, you can do the access request to the service producer. And before that, authentication was already done. Now you're doing the authorization part, whether for how long I can access it and whether I can access it or not. And this service producer will validate this post-quantum JWT token using PDP's public key, and then only the service can be done and the service consumer and producer can talk. And do small businesses even care about PQC? So this was one of the poll that I did on small businesses communities group. I really wanted more participants, but I mean, it was fine for the first time. I was not expecting much more involvement. But anyways, so they were like, to be honest, there were like 5 to 7 people, maybe like 7 to 10. But they were like, comments were 15, 14. There were 14, 15 conversation between them. And the number looks small, but when you think it in a way that you are in an offline mode meeting 7 of the people, then it's actually really good. You're getting views from different areas. So what were the results were? 33% of the small businesses, they've already started implementing PQC solutions. And for 25%, they were aware about PQC, but not actively planning. And 25% were like researching and evaluating our options. And for 17% cases, some solutions were already migrated to quantum resistant. So this is the overall idea of small businesses, although more than 50% didn't involved in this one, but hopefully maybe in some time we can interact with them. If you want more discussion like this on different topics, then you are all welcome to join the small businesses one. And you can also join the individuals community. We are focusing more on the community engagement. We can get so that we can get more involvement, more feedbacks, and then we can align our ideas with the users, with the small businesses, large businesses, whatever. So please give it a visit, and please join. If you have any question, whether you come from small businesses or individuals, you can directly come to me and ask me, hey, I don't like this about OpenSSL. And then I'll discuss this with the TAC team, I'll forward the message to the director, and if it's a major concern, we'll do it anyways. And that's a post-quantumized buy from my side. Any questions?
Poll you did on the small businesses community. So were all 7 of the people that responded from different small business? So like it was 7 small businesses that had responded? Okay.
Yes, yes. There are not a lot of members in the small businesses as of now, but James and I, as the back member, we are planning a lot of things. We have to do offline as well as virtually, and we are creating a lot of channels that we can talk about. We are engaging more with the small businesses now. The foundational face-to-face meeting was really helpful, so we have a lot of plans, and hopefully we do it. Yeah, thanks. Yeah, John.
Do you have a sense if small businesses are moving faster because they have, lighter processes and all that sort of thing, or do you think that they're moving slower for, that the pressure isn't on them?
Well, ideally, they should do the first one. They should migrate faster, but in a lot of cases, they are still relying on the large businesses. Oh, that's AWS cloud. We'll take care of the PQC. I don't really need to care about anything. Or if they are using cloud native architecture like Kubernetes, they are saying my Kubernetes security will take care of this. But what they really need to do is at least try to find out what actually they are using. Don't rely completely on someone else. And since we say zero trust architecture, so what zero trust architecture says is on every level you need to provide the security. So at the end of the day, whether it's your source code, you also need to provide you on that level. Kubernetes or any platform by default will just provide security between 2 services point or gateways. But once the data comes inside your code level logic, let's say this is your gateway, the data between this gateway and your application logic, this part is still insecure, not secure, sorry. So that also you need to take care of. So small businesses, they need to migrate faster, but they are still relying on large businesses platform and all. Yeah.
And unfortunately, that is our last question. Please, everybody find Aditya during the coffee break and hound him with even more questions. He's happy to answer.
Yes.
Thank you so much, everybody.